Now the next topic is phase representation. Phase representation. So we are discussing AC circuit analysis. We are discussing about the AC waveforms. AC waveforms having magnitude as well as phase. So now we will discuss what is phase. First thing you have to remind it, DC supply is a scalar actually. DC supply is a scalar. Scalar means it doesn't have any direction. Like this directly it has some value. But AC supply is a vector. Vector means it has, AC supply has one magnitude, every AC has some magnitude and as well as phase. Magnitude as well as phase. So that's why from this we have to understand what is phase representation, right? So in order to understand this, just take it small example. Up to now we discussed about the voltage, that's why I consider current. Regarding currents, current or voltage, anything is same. So first I take a waveform, that is I1 of t equal to Im sin omega t. So generally Im sin omega t, you know that the simple waveform is start from 0, a sinusoidal waveform. We have Im, that's why positive wave is plus Im, negative wave is minus Im. So omega t always sinusoidal waveform has time period of just 2 phi. Just consider the 2 phi, a simple thing, omega equal 2 phi f. That's why this is the waveform. For that, this waveform, this is AC supply. This waveform has magnitude as well as phase. The phase is represented with this omega t, coincide with this omega t, any phase. Here there is no phase, means actually there is no, that means have some 0. Simply mind it. Nothing means it has 0. That's why I can write is the I1 of t has magnitude of I1 of t, the magnitude of I1 of t, and the phase is 0. Phase 0 means a simple thing, it start at 0 radians. Phase 0 means it start at 0 radians. Why? The units are radians only. So I1 of t, better to take this is omega t also, nothing is I1 of t or I1 of omega t, both are same, simple. And so that's why we can write, just draw a line, that line have the angle of 0 degrees. The straight line means it is a 0 degrees. Just write your magnitude I1 of t, just drawing with the red marker I1 of t. This is about the magnitude I1 of t, and this is the direction. Why it is straight line? Actually it is a 0 line. Actually it is the 0 line, the same phase, both are in same. I think understand now phase. This is the magnitude, this is the phase, starts from 0. If you observe second waveform representation is like this. I2 of t Im sin omega t minus phi. Always phase coincide with the omega t. That's why the waveform starts with after phi angle. I think phi angle is like this. After phi angle I consider this is the phi angle. This is the phi angle. So after phi the wave will start. But wave has same time period. Same time, it starts from the here, and after that this is a 5 plus phi, after that 2 plus phi. The complete time period is 2 phi plus phi minus phi, 2 phi only. So that's why the time period is same, no change in time period, but the wave starts after phi. The reason is omega t minus phi. If you write some 0 here, you will get minus phi. Omega t, some 0 here, omega t, you will get. Understand? Right, like this. It starts from phi. So look at here, phi, 2 phi, 3 phi, 4 phi, like this. Time period is same. But what is the difference between these? We will represent with the phase difference. That is, the phase, the vector is I2 have some magnitude of I2 of t as well. Now the phase is minus phi. Just write your minus phi. Understand? Here 0, just I written the phase is 0. That means it will start after 5 radians. Look at here, -5 means starts waveform after 5 radians. So then the phasor diagram, this is name it as the phasor diagram. The phasor diagram is, this is the 0 reference wave after 5. So downwards 5 we have the I2 of t. I2 of t or I2 of omega t. I2 is the current waveform, but the difference is this direction have some I1 of t magnitude, this direction I2 of t magnitude. The difference between the first wave and second wave is the direction. The phase represents the direction. Start which the wave at which point starts represents. So this is about I2 of t. Next I3 of t. I3 of t is like this, Im sin omega t plus phi. If it is plus phi, simply plus phi means it starts somewhere 5. If it is 0, it shows the phi value, but the time period is same. Again time period is same, time period is same. So it's come forward. So it will start some late, it will come forward. For that you have to write the vector. I3 of t has some magnitude, I3 of t has some phase, that phase is this plus phi. So I am writing this plus phi. Again we have 0 reference vector, plus phi means up, plus phi means up. So plus phi, the current is I3, I3 of t. So this is the representation. Now you will understand phase. Phase means simple, the wave starting point where it starts shows the phase, and it will shows the direction, which direction it has to go, the wave has to go. Here 0 phase means it has 0 direction. It has -5 means, -5 phase means it has some lag, it is called as lagging. So -5 means it is named as the lagging. Lagging means it will start some late. So that's why I2 of t is lagging. Plus 5 means this is called it as the leading. It is named it as the leading. Leading means it will start lead means the forward, it will start the backward. Understand? It will start at that point, no phase at that point. This is about the phase representation. You have to understand the phase representation first, the equation and the diagram and the vector representation. Okay, I think all of you understand. So which has starts with late is known as the lagging, which has some forward is known as the leading. Right. So now we will see two problems, then you will easy. First problem is, now you will better to take the I1 of omega t. I1 of t, I1 of omega t, don't confuse, both are same. So just I1 of omega t I consider. So V of omega t. Simple. First represents the phase, draw the phasor diagram. Just question is draw the phasor diagrams. Right. Here first thing, for that I1 of omega t has some magnitude. So we don't need to find the magnitude. This is about the magnitude. What about phase? Phase is -20. Phase is -20. Whichever is available, just write -20. So now the phasor diagram is, this is the reference wave actually. This is the reference wave. So I1 of t has a magnitude, we don't know, but we will find out later. Just keep in your mind, I1 of t is the magnitude. So it -20 means somewhere, we don't know, somewhere such point. That is like this. Understand? Lagging, -20 means lagging downwards. So this is I1 of omega t phase representation. The second thing is V of omega t equal 100 sin omega t plus 30. For that, a simple thing, same V of omega t is the magnitude actually. V of omega t is the magnitude. What about phase? What about the phase? Phase is, look at here, this is a plus 30, directly write just plus 30. Now you have to draw this. Just first draw the reference waveform. For that we have V of omega t. V of omega t have some plus 30. Just keep here plus 30 and V of omega t. V of omega t has some magnitude, it has some direction. It has some direction. For any current or voltage in AC supply, phasor representation is like this. The use of application of phasor representation means it will show difference between the waveforms. It will show difference between the waveform. We have some differences. Every time you have to draw this sinusoidal waveforms representation is very difficult, and it will take more time. So in order to simplify this, just phasor represent, direct representation, simple diagrams. That's why we are using the phasor representation. Okay, this is about the phasor representation. Phase means the angle, the phase means the starting point. The phase means the starting point. I think all of you understand. Okay.